Hello, welcome to Target IS. I am Prakash Rajput, and today we will see electric field intensity due to line charge distribution. In the previous class, I have told you about the electric field intensity and some types of charge distribution which are there, like point charge, line charge, surface charge, and volume charge. So we will see electric field intensity at a point due to line charge distribution. So here I have considered a line charge. This is shown as green. Suppose this is a finite line charge. I am considering right now a finite line charge. Suppose this point is A and this point is B. So it is from A to B, and this is on the Z axis. And suppose this has a line charge density of rho L. This has a line charge density of rho L. And I want to find field at a certain point. Suppose in the coordinate system I am finding at this point P, and it has some coordinates rho, phi, and z. So what will be the z? Z is actually distance from the z axis, as you remember from the cylindrical coordinate system. So this will be from here to here. Actually this will be rho. This will be rho. So if I remove this point, because p and rho will confuse sometimes, so this is rho distance, that is perpendicular distance we can also say, and I want to find at this point uh, electric field. So I have to consider a small length here. Suppose that small length I am considering here, and it has a displacement vector up to this point. So let's say r12. So and I have to write coordinates of this point as well. So what will be the coordinates? The value of rho for this will be 0 because it is on the z axis, and here phi will remain the same because it will be in the same direction. So phi here, or here phi will be same, and some distance. Suppose this distance is z dash, as this is considering I am considering as z. So suppose this distance as z dash. So what will be the r12 vector? It will be field point minus the source point which I am considering. So rho minus 0, it will be rho arrow cap, plus phi minus phi will cancel each other, and z minus z dash will be az cap. And let me write the magnitude of this. It will be under root of rho square plus z minus z dash whole square. This will be the magnitude of this r12 vector, that is the displacement vector from the source point and field point. This is required as the formula for electric field. I have told you in previous class. Suppose this is the small small unit of charge, line charge. So due to this there will be electric field, suppose dE, and from the formula it will be 1 by 4 pi epsilon naught. And what is the charge? It will be rho l dl for line charge, and r12 magnitude cube in the direction of r12 vector. This is the formula due to this small line charge. So if I have to find the whole electric field for the whole line charge, I have to integrate this. I have to integrate on both the sides. So let us consider some more things. Consider at this angle as alpha. Consider this angle as alpha, and I will write all these r12 vector. Suppose So I move this R12 here from here so that I can draw some things which I have to draw here. So suppose if I join this point as well, so and take this angle as alpha 1, and if I join this point as well from the point of interest, that is this, and from the perpendicular distance I consider this angle as alpha 2. And let us find some more things for this. If I have to find tan alpha, if I have to find tan alpha, so here from the red pen you can see in this right angle triangle, tan alpha will be perpendicular divided by base. So what is the perpendicular? The distance. The point here it will be the value is z, and here it is z dash. So what is this distance? Z minus z dash. And the base is the distance rho. So tan alpha is rho. I have to use this, that's why I'm writing this earlier. So it will be rho tan alpha, rho tan alpha. Now putting all the values in the formula, here integration of dE becomes the total electric field, that I will write E, wait, here E vector will be equals to 1 by 4 pi epsilon naught. This rho L and 4 pi epsilon naught will come out. So if I write this as rho L upon 4 pi epsilon naught, and the dl will be the differential length here. It is on the z axis. So I can write, as I am taking this as z dash, so I can write as dz dash. So I can write the differential length as dz dash divided by r12 magnitudes cube. So what is the r12 magnitude? It is this. It is under root, and its cube will become power 3 by 2. So I can write rho square plus z minus z dash whole square to the power 3 by 2 to the power 3 by 2. And for r12 vector I can write this value, which is here cap rho a rho cap plus z minus z dash az cap. This is the value of r12. Now I can write z minus z dash as rho tan alpha here also, and I can replace dz dash by differentiating this. So differentiate this, it will be z is a constant number for constant for a certain point, so it will differentiation will be 0. Here minus dz dash equals to rho is constant for a certain point, so rho will be constant, and tan alpha will differentiate as sec square alpha d alpha. So I can write rho sec square alpha d alpha. So I can replace dz dash by minus rho sec square alpha d alpha. So if I write this in formula, this will become rho L by 4 pi epsilon naught remains the same, and in place of dz dash I can write minus rho sec square alpha d alpha divided by, in place of rho square it will be same, plus z minus z dash. In place of this I can use this expression rho tan alpha, so its square will become rho square tan square alpha to the power 3 by 2. And here rho a rho cap will remain same, plus z minus z dash, again I can write rho tan alpha and az cap, az cap. So now simplifying this, I can take the minus sign common, so it will be minus rho l by 4 pi epsilon naught. So I can take minus sign common, and after that here rho I can take common, so it will be multiplied by this integration. It will come as rho square sec square alpha d alpha, and here remaining things a rho cap plus tan alpha az cap divided by, so you can see rho square is common here. If I take this common, so rho square and this power will cancel and rho cube will come out, and the remaining thing here will be 1 plus tan square alpha to the power 3 by 2, and simplifying again, rho l by 4 pi epsilon naught, rho l by 4 pi epsilon naught, here integration, and this power and this value will be cancelled, so remaining here it will be rho, and 1 plus tan square alpha is sec square alpha, so again the sec square alpha and the power 2 will cancel, and the thing which will come out is sec cube alpha, and remaining sec square alpha d alpha, and it remains the same, a rho cap plus tan alpha az cap. So now minus rho l by 4 pi epsilon naught, here sec square alpha and this value will be sec alpha will remain in the denominator, and I can take this out from the integration because it is constant with respect to alpha. So the remaining thing is d alpha and this sec alpha only, because this will cancel and this power will cancel, so remaining is sec alpha. So if I multiply here, so it will be 1 by sec alpha, so it becomes cos alpha a rho cap plus tan alpha, I can write sin alpha divided by cos alpha, so I will write sin alpha by cos alpha, and this sec alpha will be multiplied here, which will become, if I take it in a denominator numerator, it will become cos alpha like this, and az cap, and the thing remaining is d alpha, d alpha. So now things which are cancelling each other is cos alpha, and the remaining things are rho l divided by 4 pi epsilon naught rho integration of cos alpha, integration of cos alpha a rho cap plus sin alpha az cap, and here it is d alpha, and we also have the value for limits of alpha. What were they? What were they? They are, I'm going from a to b, so alpha is changing from alpha 1 to alpha 2, alpha 1 at this point and alpha 2 at the b point, so I can write the limit as from alpha 1 to alpha 2. So writing limits here alpha 1 to alpha 2 and integrating it now. Now you can simply integrate it. So here minus rho l by 4 pi epsilon naught remains the same. Cos alpha integration will be sin alpha a rho cap plus sin alpha integration will be minus cos alpha az cap, and the limits of alpha are from alpha 1 to alpha 2. Now putting the limits, what it becomes? Rho L divided by 4 pi epsilon naught rho, and here it will be sine alpha 2 minus sine alpha 1. Sine alpha 2 minus sine alpha 1 a rho cap plus. So here it is minus. So if I write minus cos alpha 2, then minus of minus minus cos alpha 1. So it will become cos alpha 1 minus cos alpha 2. Here a z cap. Here a z cap. I'll close the brackets. Now you can simplify it further. Here the minus sign I can take and multiply. So here rho L by 4 pi epsilon rho, and if I write, this will become sine alpha 1 minus sine alpha 2 after multiplying the negative sign, a rho cap component plus, and this will become cos alpha 2 minus cos alpha 1 az cap, the z component. This is the value of electric field due to line charge distribution, or I can say finite line charge distribution. But you can use this for any line charge distribution, any. If it is infinite, we can find the value. We will see that cases also. This is the final value of the electric field due to line charge distribution, rho L divided by 4 pi epsilon naught rho sin alpha 1 minus sin alpha 2 a rho cap plus cos alpha 2 minus cos alpha 1 az cap. So this is my final formula for electric field intensity due to finite line charge. So it is the formula. Now let us see some different cases, like if the line charge is not finite, it is infinite. Line charge is not finite, it is infinite. Then what will happen? So if I consider a infinite line charge, suppose this is my line charge which is infinite length. Here consider as it is plus infinity, and in the bottom side we can take as negative infinity. So here I can mark as negative infinity, and I want to calculate field at this certain point. So if I join this, so what you can imagine, it is infinite. It is infinite. So, and suppose this perpendicular distance is rho. So from the lower end I have taken the angle alpha 1, and from the upper end I have taken the angle alpha 2, as you can see from the figure. Here lower end I have taken alpha 1 and upper end I have taken alpha 2. So what you can imagine is, for infinity what this angle will become. For infinity alpha 1 will become pi by 2 and alpha 2 will become. Now in the previous figure which I have drawn, in this alpha 2 was on the downside. Now here alpha 2 has become on the upper side, which for the infinite. So it is also pi by 2 but of negative, because it has gone on the upside, ऊपर की तरफ चला गया वो, इसीलिए अल्फा 2 को हम कंसिडर कर सकते हैं एज माइनस पाई बाय 2. अब ये पाई बाय 2 और माइनस पाई बाय 2 क्यों लिखी? क्योंकि ये इन्फानाइट पर है, तो इन्फानाइट पर तो कभी एंड ही नहीं होगा, तो ये सीधे सीधे चला जाएगा एट द परपेंडिकुलर. So these angle will be large enough, we can say that these angles are 90 degree and minus 90 degree. Now putting the values of these alpha 1 and alpha 2 from the in the derived formula, which is, if I show you, which is this here. So put the value of alpha 1 here. If I write E is equals to rho L by 4 pi epsilon rho. Sin alpha 1 is, I have told you it, I am taking alpha 1 as pi by 2 because at infinity it becomes pi by 2, and if the angle is on the upside I can take it as minus pi by 2. So put the value sin pi by 2 and minus sin alpha 2 is minus pi by 2, arrow cap, plus, so cos alpha 2 minus cos alpha 1, if I put cos pi by 2 it becomes 0 minus cos alpha 2 is minus pi by 2, but cos of minus theta is cos theta, so cos pi by 2 becomes 0 and cos alpha 1, that is cos pi by 2, will also become 0. So this component will eventually cancel it, so it becomes 0. Only the remaining component is this. Now sin pi by 2 is 1, sin minus pi by 2 is minus sin pi by 2, that is minus 1. So minus of minus will become plus 1. So it will be rho L by 4 pi epsilon naught rho 1 plus 1 simply. So 1 plus 1 is 2 and this will cancel this. So I can write the electric field for an infinite line charge. It comes as rho L by 2 pi epsilon naught rho. So in this we need not know to we don't know we need not to know the angles, because alpha 1 and alpha 2 has become 90 degree. So directly if we know the perpendicular distance only, we can find the electric field at a certain point due to the infinite line charge. So this is my case 1. If the infinite line charge is there, so this will be the formula for finding the electric field, rho L divided by 2 pi epsilon naught rho. And if I write the vector, it will be in the direction of arrow cap, because arrow cap is remaining, az component has become 0. So this is the formula and with the direction. So now we will see case 2. Now case 2 is my field point is such that it is in the middle of the line charge. By middle I mean this perpendicular distance is bisecting this line charge. So as this is bisecting, this angle's magnitudes will be constants. Alpha 1 will be equals to alpha 2, but the sign will vary because alpha 2 is in the upside, so it will be, I can say, alpha 2 will be minus of alpha 1, alpha 2 will be minus of alpha 1. So if I put this in this formula which I have derived earlier, the field becomes rho L by 4 pi epsilon naught rho sin alpha 1, I can write sin alpha 1 as it is, minus sin alpha 2. Alpha 2 is nothing but minus of sin alpha 1, and you know that sine of minus theta, what it becomes, minus sin theta. So I can use this here and I can write minus sin alpha 1, and if I put the vector as arrow cap and then plus cos alpha 2. Alpha 2 is minus alpha 1, and you know cos of minus theta will be cos theta. So I can replace this as cos alpha 1 only, minus cos alpha 1, and the unit vector is az cap. So here you can see that this cos alpha 1 and cos alpha 1 will cancel, and the remaining thing is minus of minus will become plus, and sin alpha 1 plus sin alpha 1 will become 2 sin alpha 1. So the final formula for this case will become rho L by 4 pi epsilon naught rho. Here it will be 2 sin alpha arrow cap, which we can write it as rho L by 2 pi epsilon rho sine alpha 1, sine alpha 1 aero cap. So this is the formula when the field point is like that if the perpendicular distance is dividing or bisecting the line charge. Field point is and the perpendicular distance is bisecting the line charge. So these angles becomes like this. Alpha 2 is equals to minus alpha 1. So the final formula will come rho L divided by 2 pi epsilon naught rho sine alpha 1 in the direction aero cap. You can also see the direction with logic also with analyzing the figure. So if I'm finding due to this point I'm finding electric field at this point. So it will be in this direction. It will be in this direction. If I write this by different pen, so it will be in this direction. If I resolve the components, it will be something in this direction and in this direction. And if I find due to this point which is at the lower end, so it will be in this direction. And if I resolve this, it will come in this direction and a component will come in this direction. So similarly you can also find from certain points, and like if I consider this point and due to this it will be in if I consider this point and if I join this point and this will be in this direction, something different. So if I resolve this, this has a component in this direction and this direction. Similarly at same distance here, if I find electric field due to this and join this, so this will also have some component in this direction and in this direction. So you can see that these components are getting cancelled out. The z component, because it is placed on z axis, which, as we have considered, so the z component will cancelled by the upper part and the lower part, and the final outcome will come in the rho direction. In the rho direction. That's why in the formula also you can see only the rho component is present. Only the rho component is present. So this is the formula for this case if the point is such that the perpendicular distance is bisecting the line charge. There is one more case. Let us see that. Now let us see this case. If the field point is near to one end of infinite line charge. This is my infinite line charge and my field point which on which I am calculating the field is near to this end. So here the value of alpha 1, what it will become, as it is near to infinite, so it will be in the same direction. It will be in the same direction. And if I consider this perpendicular distance as rho, as rho, so alpha 1 will become in here in this case 0. Alpha 1 will become 0. So only thing remaining is alpha 2. Now it is at plus infinity. So what it will become? It will become alpha 2 is equals to pi by 2, but it is on the upside, so minus pi by 2. So I can write these in this formula which is the derived one. So what will be after putting the values? Rho L by 4 pi epsilon naught rho. Here sine alpha 1 is 0, so sine 0 will become 0 minus sine alpha 2, and it is minus pi by 2. So sine minus pi by 2 will become minus 1. So minus of minus will become only the aero component. Aero component. And now here cos alpha 2, cos pi by 2 is 0 minus cos 0. Cos 0 is 1. So it will be minus 1 az cap. So this is the formula for this case when the one end is near to infinity. You can also consider the this point at on the upside, and you can find the respective formula for that. You just need to remember the derived formula, which is for the finite line charge we have found. This one. You can find easily the other cases. So here, for this case, it is a rho cap minus az cap. This is the formula for this case. Now let us quickly see this problem. Here rho L is given 10 nanocoulomb per meter is at this location. Is at this location. And we have to find electric field at this location. And given line charge is an infinite line charge. And you know, for a infinite line charge, we have derived a formula that is rho L by 2 pi epsilon naught rho 2 pi epsilon naught rho in the arrow direction. And what is this arrow? It is actually the perpendicular distance direction in which the line charge is present. So you don't have to confuse this by the arrow. Sometime when we have considered this formula, when we have derived this formula, the line charge was on z-axis, but here the line charge is at the location y equals to 3 and z equal to 6. That is, it is parallel to the x-axis and it is passing through these coordinates of y equals to 3 and z equals to 6, because for a line to define, it has two constants and one variable. So in the formula we have to find this rho. What is this rho and this vector? So if you know that for finding these arrow cap and rho, you have to find the displacement vector, which is easily found out by field location minus the source location. Field location is at which I am calculating the field. So field location क्या है? 7 ax cap plus 8 ay cap plus 9 az cap. Now what will be the source location? As it is a line, so and we were finding perpendicular distance. So the value of x I have to take here 7 ax cap, and the remaining value will be will be 3 and z. That is 3 ay cap plus 3 az cap. If you solve this, 7 and 7 will cancel and 8 minus 3 will give you 5 ay cap plus 9 minus 3 will give a 6 az cap. 9 minus 3 will give, actually this is 6, and here 9 minus 6 will give you 3 az cap. So this will be the r12 vector, and the perpendicular distance will be the magnitude of this vector. Perpendicular distance will be the magnitude of this vector, that is under root of 5 square plus 3 square will be 5 square is 25 and 3 square is 9, so it will be under root of 34. And the arrow cap will be r12 vector by r12 vectors magnitude, so it will be 5 ay cap plus 3 az cap by root 34. So if you put these values in the formula, what E will come? Rho L was given in question as 10 nanocoulomb, that is 10 into 10 ki power minus 9 by 2 pi. Now epsilon value we can take here 1 by 36 pi into 10 ki power minus 9, and the distance, perpendicular distance which we have calculated, root 34, and the arrow cap, the unit vector, it is 5 ay cap plus 3 az cap by root 34. And if you solve this values, 10 raised to minus 9, 10 raised to minus 9 will cancel, 2 pi, this will be 18 and it will go on the numerator, so it will become 180, and this root 34 into root 34 will make it 34. So 180 by 34, 5 ay cap plus 3 az cap. So this will be the final answer, and its unit So very careful for the units. So its unit is volt per meter, or you can write as Newton per coulomb also. So this is the solution for this problem. Here where when we were finding the unit, when we were finding the R12, so you can also note that here if the to line charge is parallel to x-axis, so here the value of x won't matter for the field location. This value won't matter for field location because we will be anyway taking the we will be taking anyway the equal value. So if you want to just exclude this, you can you should not take this, मतलब आप इस वैल्यू को लो ही ना तो भी चल जाएगा. You can directly take these values and these values because we will be finding the perpendicular distance, and this value we have to take same. So this will be independent of the x coordinate of the field point. So if a question like this comes like it gives this location as suppose something like 7, 3 and 6. Now this point will be on the line. If it's something like this 8, 3, 6, this point will also be on the line. So it will not depend on this point, this value of x, because it is parallel to x-axis and passing through the 3, 6 of y and z. So you can directly find the values at this point and this point. It will be same for every location on the x-axis, and it will be 0 only. Sorry, not 0. So value of E will remain same for every coordinate if we change only the x-axis. It is independent for the x value if it is parallel to x-axis, and if it is parallel to y-axis, so obviously for y value it will be independent, and so on. So that will be all for today. We will meet in the next lecture. Thank you.